the inverter converts the DC current, positive and negative DC coming from the battery, into AC power, hot, neutral and ground for single phase, or hot, neutral and ground for double phase or three phase. This is an equipment, this is an expensive equipment with an special characteristics. We are going to study in details how the AC power is produced on the inverter. Suppose that this is the DC signal. That's the positive side of the DC signal, and this is the negative. Voltage and time. If you interrupt the positive signal in sections, if you cut it, the signal with the transistors and capacitors, the positive and the negative with transistors and capacitors, you cut it, and after that you pass that current, interrupted current, through a coil, and the coil is the primary coil of one step-up transformer. This is a step-up transformer. If you remember, in our previous chapter dedicated to transformers, I explained to you there are three types of transformers: isolated transformers, step-up transformers, or step-down transformers. How are the signals produced on the output of the inverter? Those are the most typical signals produced in the output of the inverters. Square signals, or triangle signals, or a signal like this, small segments. This is the best. In our class of electronics, we are going to use the oscilloscope to check the output signal of the inverters to verify, and we are going to verify that this is the typical output signal produced for inverters. Depending of the quality of the inverter is the output signal. There are inverters with high quality, but those inverters are expensive inverters. And there are inverters, cheaper inverters. Those inverters produce triangle signals or square signals. I am going to explain the procedure to calculate the capacity of the inverters in kilowatts, and I am going to explain the procedure to install the inverter on the boat. Remember, the inverter is one of the three sources of AC power. One source of AC power is the shore power, the second one is the generator, and the third one is the inverter. The inverter have a couple of inconveniences. One inconvenience is that the output signal is not a perfect sinus signal, it's like a little square, and additionally the output signal from the inverter doesn't have frequency. For that reason, the power produced for the generator is used only in emergency, and is used for some equipment, not for all the breakers in the AC panel. Why? Because if you use the power produced from the inverter for all the breakers, you need a lot of batteries to supply power for those equipment. The inverter, normally, this is the typical connection of the inverter. The inverter at the input receives power from the group of batteries. The group of batteries, they have a main switch. This is the switch. It's a typical main breaker or main switch like this. In order to connect and disconnect the power, the input power DC to the inverter. The input power DC enter into the inverter, and the inverter convert the power into AC power. That source of AC power goes into the switch selector in the position inverter. There are other positions for shore power and other positions for generator. Okay, in this particular case, the DC power is converted into AC and enter in the position inverter. Alright, I need, according with our example, 20,000 watts. I need 20 kilowatts. Alright, this is the power that I need in the AC side, in this side. The power should be the same. The power produced in AC is coming from the power entering in the DC side. Okay, if I need 20 kilowatts over there, it's because I have 20 kilowatts. What is the formula for power? The formula for power is voltage times intensity. How can I add it 20% easily? Okay, the recommendation is, okay, we are going to divide it, no for 24. We are going to divide it for 20, and this is the safety factor. Okay, is 20,000 divided by 20, 1,000 amps. This is the amount of amps that I need at the input of the inverter in order to produce 20 kilowatts in the output. 1,000 amps in order to produce power for 1 hour. Oh, I need those equipments working constantly for 3 hours. You need 3,000 amps. Normally the inverters, the marine inverters, they have on the label, the inverter, the label says inverter slash charger. And normally if you check the AC panel of any boat, if you check the AC panel, this is the AC panel. The power from the AC panel is coming from the switch selector. The switch selector receives power from inverter or from shore power or from generator. Okay, normally in a typical boat, on the AC panel you found that one breaker with the label inverter slash charger. Some people say this is the breaker in order to activate the inverter. No. The inverter is activated, remember, from the switch selector that supplies the DC power. This is the breaker or switch selector used to activate the inverter. The switch selector is located here in order to interrupt the positive at the input of the inverter. That's the input. That's in some cases you install, instead of the switch selector, you install one breaker. That's the breaker to activate the input of the inverter. In the output of the inverter, the majority of the inverters, they have two divisions. They have hot line, neutral and ground for output, and they have hot line, neutral and ground for input. For example, this battery is a Sirius HD. This battery is an excellent battery. This battery have a capacity of 800 amps per hour. It's a good capacity. Or those batteries are Sirius 27. Those batteries only have 100 amps per hour. Oh, in this particular example, I need 1,000 amps per hour. Okay, with two batteries of this, I have 1,600 amps per hour. This is a good selection. The secret is select the appropriate batteries in order to keep a good group of batteries properly installed, properly organized, in order to supply the amount of AC power required for the customer in the boat. A couple of additional things related with the ABYC study guide specific for the chapter 6 inverters. In the ABYC study guide chapter 6, there are important recommendations that I want that you read carefully. For example, one of the recommendations is in relation to the capacity of the inverter according with the capacity of the battery bank. The capacity of the battery bank for any type of marine inverter should be no less than 800 CCA. 800 CCA is the minimum according with ABYC. Other important recommendation is install the inverter separate as close as possible to the battery bank, but not over the battery bank. It's logic because if you install the inverter over the battery bank, the gases, the fumes from the batteries affect the circuit boards on the inverter.